Alright, so let's take a look at, look for the leading term. So we take the a with all the factors that have an x in it also. So right here, negative x cubed, and right here the 2x. So negative x cubed times 2x. So this gives me negative 2x to the fourth. So that's my leading term. So the degree is even, and and the a is negative, so that means this is a down down. Okay, and because this is a down down, as x goes to infinity, f of x or y also goes down. So this is here. As x goes to negative infinity, as we go to the left, f of x goes down. So both y's, the left and the right side, both go down. As far as the zeros, for the first factor, for this one right here, that 0 is 0. And for the second factor, now we haven't encountered something like this in the homework before or in the examples. So all you do is you're looking for what value here makes this whole thing right here 0. So let me show you the steps right here. You take the factor, you set it equal to 0, and you solve. That's all there is to it. So we're going to add 3 to both sides. So that gives us 2x equals 3 when you add 3 to both sides. Then we're going to divide by 2 on both sides. So when you divide by 2 on both sides, you get x equals 3 over 2. So that's my other 0, 3 over 2. The multiplicity of 0 is 3, and that's an odd number. The multiplicity of 3 halves is 1, and that too is an odd number. So then we know that the graph is going to cross through each one of those zeros. For the y-intercept, I've already replaced all the x's with zeros, so now we just simplify. So negative 0 cubed is 0, and 2 times 0 is 0 minus 3, and that still gives me 0. So the y-intercept is 0, 0. Okay? Okay, so here's the setup for the graph. We made sure that 0 and 3 halves fit on the x-axis. So let's go ahead and plot those 2 points. So 0 and 3 halves. So 3 halves is 1.5, so approximately right here. The y-intercept is 0, so it's already on there at 0, 0, so that's all we need. And the graph is going to cross through both points. So, and the end behavior is down, down, so I know that it's coming in from the bottom like this, and then coming out through the bottom like this. Okay? And so at some point it's gonna be going up, and it's gonna come down, and it's gonna curve down like that. Okay, and the reason I made like a little flatter curve right here is because this 0 has a multiplicity of 3, and x cubed kind of has that, remember the cubic function, it has that, little curve like that, so that's why I did that. So let's go ahead and look at Desmos. Okay, so notice we have down, down, so we do the same, it looks the same in our graph. We have the 1.50, and it's crossing through. We have the 0, 0, and it's crossing through. Okay, and our maximum was in between 0 and 1.5, so it's actually, this is where it actually is. So this graph, because it's a down, down, it has a global, in this particular one, it has a global max. So right here is a global max. Okay, so that's the highest point in the whole function. It has no local max or min. I guess the global maxes could be referred to as a local max if we're only looking at this region right here. But looking at the graph as a whole, this is a global max. Okay, so let's go find the leading term. So we're going to take the a value times x cubed times x squared. Okay, so it's 1/2 times x to the third times x squared. So that's going to give me a 1/2 x to the 5th. So this tells me that it's going to be a down up because the degree of the polynomial is odd and the a is positive. So on the left side it's going to go down, on the right side it's going to go up. Okay? So in end behavior notation, it would look like this: as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. So on the graph, it would go on the left side down, on the right side up. Okay, for the zeros, the first factor that has an x, this one right here, the zero for that one would be 2. And for the last factor with an x plus 1 would be -1. The multiplicity of 2 is 3, so that's odd number, and the multiplicity of -1 is 2, so that's an even number. So the graph is going to cross at 2, 0, and it's going to be tangent at -1, 0. Okay? So now we're going to find the y-intercept. It's already set up for you, so it's 1/2 times the quantity of 0 minus 2 cubed times the quantity of 0 plus 1 squared. So 1/2 -2 cubed and 1 squared. Well, 1 squared is 1, and -2 cubed is -8. So that gives me -4. So 0, -4 is my y-intercept. Okay, so look at my x and y axis. Making sure that the zeros, the x-intercepts fit on the x-axis. I've also labeled the 0, -4. So let's go ahead and plot the two x-intercepts. So 2, 0, -1, 0. Then the y-intercept. Okay. The end behavior on the left, it's going to come down, and on the right it's going to go up. And so now I'm going to connect the points. Okay, so I noticed that on 2, at x equals 2, the graph is going to cross. So I'll start on the right side this time. It's going to cross. It has to make sure you go through 0, -4, and then when you get to -1, you bounce off. And there's the graph. Let's compare it to Desmos. Okay, so here it is. Notice how I typed in the equation instead of the fraction, I put the decimal. Same thing. Okay, at the time I just found it faster to put 0.5 rather than 1/2. Same thing, no difference. Because this is an up down, and again compare it to our picture, we got a down up just like this one right here. So the left is going down, the right is going up. Our graph is also going to 0. It's going and it's crossing through, and at -1 it is tangent, and we also got a 0, -4 for our y-intercept. Notice that there's a lower point right there, the gray one. I didn't label it on purpose because then the label would go over, they would cover each other up. So I just figured, the gray dot is enough. You could see that there is a lower point. So this one, because the ends go in opposite direction, this one does not have a global max or min. So this one has no global max or min. Okay? It does have a local max. See at this turning point right here? This is considered a local max. And this is considered down here, this gray dot is considered a local min. Okay? Okay, for 5 through 7, you were given a graph and then asked to determine if the degree was even or odd, the zeros, and the end behavior. So let's take a look at number 5. Because both ends go down, down, left and right, then we know that this is an even function. And I know I didn't ask you this in the homework, but Because it's down, down, we know that the leading coefficient, the a value, is negative. The zeros are at plus and minus 2 because you have, it goes through here and it goes through here. So we can just write it as plus or minus 2. And since both the left and the right side go down, as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. So as x gets bigger, y gets smaller, and as x gets smaller, y gets smaller. Okay. Number 6, both ends of the graph go up, so this is another even function, but this time the a is positive because it's an up, up. The zeros, if you notice, it goes through 2, 1, -1, and -2. I forgot the negative right there. So it's plus or minus 1 and plus or minus 2. Those are the 4 zeros. And since they both go up, up, as x gets bigger, y gets bigger. As x gets smaller, y gets smaller. I'm sorry, bigger. They both get bigger, sorry. It's written correctly. Number 7, the ends go in opposite direction. The left goes down and the right goes up. So this is an odd function. And because, excuse me, so down, up, we also know that the a is positive. The zeros are 3, -2, and -4. So you could put them in either order. I usually go from smallest to largest, so -4, -2, and 3. And then as x gets bigger, as x goes to infinity, y gets bigger. And as x gets smaller, y gets smaller. Okay, and that's the end behavior there.